Hi everyone, this is the BX Tech Talk and today I'm going to be introducing regression. So without further delay, let's dive into this video. So this is what we will be covering today. First, I'll be giving you an introduction to regression. Next, I will be teaching you how to train a regression model, followed by use cases for regression. Finally, I'll wrap up by giving you some questions. Now here's the introduction to regression. Regression is basically a model that predicts a numeric label based on features. Now if you're wondering what are labels and features, do not panic. I'll be explaining them really soon. Regression works by finding the relationship between variables. These variables represent characteristics and are known as features. Features are the dataset that we observe to predict the result that we want, which is known as a label. A label is simply the variable that we are trying to predict based on the feature. To put it simply, the features are the input to the model and the label is the output. Just in case you're wondering, a regression model can have multiple labels and features. Now, I'll be teaching you how to train a model. To train a regression model, we first need a dataset. We will split this dataset into two subsets, which are the training subset and the validation subset. The training dataset is used to train the model and predict the values, while the validation dataset is used to evaluate the model. Now, just to let everyone know, the following information comes from Microsoft Learn. All information in this video is from Microsoft Learn. Huge thanks to Microsoft for the helpful resources they post on Microsoft Learn. So in this scenario from Microsoft Learn, we are basically trying to predict the bicycle rentals per day based on the temperature. To start with, we use some data that includes known values for the average daily temperature feature and the bicycle rentals label. This site displays the dataset I got. I got this dataset from Microsoft Learn too. So now, back to training the model. We have to randomly pick 5 of these observations, which are basically the rows in the tables earlier. We use this to find a function, which is basically a mathematical equation. Let's call f that can use the temperature feature, which we'll call x, to calculate the number of rentals, which we'll call y. In other words, we need to define the following function. F bracket x equals y. Slide 11. So here are the 5 observations that Microsoft Learn randomly selected. Now we have the data prepared, we will have to plot these observations on a chart, which is shown over here. This will help us visualize the process. Now we need to feed these values to a function, allowing for some random variation, because you can't be sure what will be the exact amount of people renting the bicycles based on the temperature alone. In the previous slide, you could probably see that the plotted points form an almost straight line, which can be described as being a linear relationship between x and y. Now, we'll use various algorithms to determine the function, which will help us find a line with minimal overall variance from the plotted points. The updated chart is displayed below. The line we saw on the previous slide represents a linear function that can be used with any value of x to apply the slope of the line and its intercept, which is where the line crosses the y-axis when the value of x is 0, to calculate y. If we extended the line to the left, we'd find that when x is 0, y is about 20, and the slope of the line is such that for each unit of x you move along to the right, y increases by about 1.7. Therefore, our function will be calculated as 20 plus 1.7x. Now, I'll be moving on to the use cases of regression. For the first example, regression can be used to predict the amount of people in the house, which is the label based on the size of a house, the feature. For the second example, regression can be used to predict the amount of water used per person, which is the label based on their mass, which is the feature. Now for the third example. This example uses multiple features to predict the label. Regression can be used to predict the amount of goals a football player will score, which is the label, based on statistics like his teammates, the weather, and whether they are playing at home or away. His teammates' statistics, the weather, and the location they are playing on, which is home or away, are all features. This helps to predict the likelihood of him scoring better. Now, here are some questions. Feel free to answer them mentally or on a piece of paper. I'll stop talking for about 10 seconds so you can answer them. Now, I'll be revealing the answers. For the first question, features are a dataset that we observe to predict the label, and the label is what we are trying to predict. For the second question, a regression model predicts numeric values. Numeric values are basically numbers. And for the last question, the answer is false. As shown earlier in the football player example, multiple features can be used in a regression model. Before I end this video, I would like to thank Canva and Microsoft Learn. As you might already know, I use Canva for all my videos, and most information in this video came from Microsoft Learn. With that, we have come to the end of this video. Thank you for watching, and I sincerely hope you learned something today. Please like and subscribe for more videos like this, it really helps a lot.